In previous video, which is 4.7.3 part 1, I have been teaching you the center of mass. Now, in this video, I would like to teach you how to find the centroid of lamina. Okay, by the end of this section, the student should be able to find the centroid of a lamina using double integral. Now, before you know how to find the centroid of lamina, let's look at the meaning of homogeneous and non-homogeneous lamina. A homogeneous lamina is a lamina with constant density function. That means the density function delta xy is equivalent to k, where k is a constant. Whereas for non-homogeneous lamina, the density function is not a constant. That means delta xy is not equivalent to k. Now let's look at the formula to find the centroid of a lamina. The formula for the centroid of a lamina is given by this x bar equivalent to 1 over a double integral of x with respect to dA. And y bar is 1 over a multiplied by the double integral of y with respect to dA. Now, when the lamina is homogeneous, we know that the density function of that lamina, delta xy, equivalent to k, where k is just a constant. So when you want to find the centroid, you need to, when you want to find the center of gravity of that lamina, you need to find the mass. So this is the formula of the mass for this homogeneous lamina. You multiply the density function times by a, and the moment about the y-axis, you need to integrate the density function multiplied by the distance from the y-axis, which is x with respect to dA. And also you need to find moment about the x-axis, which is the double integral of the density function k times by that distance from the x-axis, which is y, with respect to dA. So when you calculate the center of gravity of the homogeneous lamina, you use that formula for x bar. So you substitute values for m to get this value, and this is the moment about the y-axis. So you notice that the k value cancels off, and you get that value, which is actually the same as the centroid of a lamina for the x bar. Likewise, for y bar for the centroid, you need to divide the moment about this x-axis over this mass, and you know the mass is just Ka, and this is the moment about this x-axis. So you notice that also you can cancel that k value to give you this value, which is basically the same as the centroid of the lamina for the x bar. So basically what I'm saying here is that the centroid and the center of gravity of homogeneous lamina is the same. Now sometimes you need to find the centroid of lamina which is symmetrical to the x-axis or the y-axis. Now if the lamina is symmetrical about the y-axis, x bar is 0. But when the lamina is symmetrical about the x-axis, y bar is 0. Now if the lamina is symmetrical about the pole, then the centroid is at the origin. So let's look at an example where the lamina is symmetrical about some axis. Now in this example 4.7.3.2, you want to find the centroid of this circular region. So this circular region is actually a semicircle, because if you square both sides of this equation here, you will get x squared plus y squared equivalent to 2 squared, which is a circle of radius 2. And of course, you know that the y is positive because y is square root of something, so y cannot be negative. So it should be above this x-axis. So this is the semicircle of radius 2. So you need to find the centroid. To find the centroid, you need to find this area. So the area of this region is actually half of a circle. So area of semicircle is half of a circle. So you know the area of a circle is pi r square. So you substitute values in here. You will get half times by 4 pi. And then you get this answer for this area of the semicircle. Next, you know this is a polar curve. So you need to change the Cartesian to polar, and then you need to change the limit to r and also theta. So the range of r is obviously from 0 until 2, and theta is from 0 until pi. So you notice that this semicircle is symmetrical about the y-axis. So basically x bar is 0. So you need to find what is y bar. So y bar by formula is 1 over a double integral of y dA. So this is the formula that we have learned before. So we substitute the a value to be 2 pi. And the y value here, we change it to r sine theta. And we change the r to the a to r dr d theta here. So we need to find that value. Okay. So the range of r is from 0 until 2. Substitute values in here for limits. Like so for theta, because theta is from 0 until pi. So that will be the limit. So when you want to integrate that value, you integrate with respect to r first. Notice that sine theta is fixed. So this is fixed. So just keep it here because it's fixed. You just integrate r square to give you r cubed divided by 3 here, and put the limit in 0 until 2. So if r is 2, then you get 8 here. 8 here. 8 divided by 2 will give you 4. So 3 you put it outside the limit, you get 3 pi. And then you integrate from 0 until pi sine theta. So if you integrate sine, remember integrating sine theta will give, with respect to theta, is actually minus of cos theta. Okay, so you then substitute values in. The upper limit is pi, so you get cos pi here. Lower limit is 0, you get cos cos 0 here. But you should know that cos pi is minus 1 and cos 0 is 1. So when you substitute, you will get here negative 1. So minus, and here is 1. So in the square you get minus 2. So you multiply by minus 4 to give you 8. So that will give your answer for y bar. So the answer for the centroid is x bar, which is 0, and y bar is 8 over 3 pi. So I hope you understand this example. If you need to change to polar, make sure you change the a to r dr d theta. And if you have y, you change it to r sine theta. If you have x, you change it to r cos theta. These are the exercises that you need to do so that you understand more of how to find the centroid of lamina. So first of all, you need to sketch those graphs here. Okay, sketch those graphs, and then you need to find the area using double integration. Remember, area is just double integral dA. So you need to choose whether the region is of type 1 or type 2 or polar. So if the region is type 1, you use A equivalent to double integral dy dx. And if the region is of type 2, you use double integral dx dy. Or if it is polar, you use double integral r dr d theta. So I hope you can find the area and use the formula that we learned today to get the centroid of lamina. So the answers are all given here. Hope you can do all of them. And if you have any problem, please let me know. Thank you.